right, so number one, 1, 2, and 3 we just prove. Prove the following. Number one, with cotan x with tan x equals to secant x times cosecant x. I'm going to start on the left. So we know using the ratio or property, this is going to be cosine x over sine x plus sine x over cosine x. At that point, is add the fractions. This is a denominator of sine and cosine. So LCD would be sine cosine. So multiply this first one by cosine over cosine. Plus sine x over cosine. So multiply this guy by sine over sine. So we will get, this is just, all we do is add fractions. This becomes cosine squared over sine cosine plus sine squared over the same thing, sine cosine. So now you can add the fractions. So this becomes cosine squared plus sine squared over that LCD. And we should know that cosine squared plus sine squared is equal to 1. This is the Pythagorean. At this point, we're pretty much done. I don't know if you see it. Maybe it'll be more obvious if I change it into this. You agree this is the same thing, right? This is going to be my cosecant times secant, which is the same as secant cosecant. This is the reciprocal identity. Sorry. That makes sense? Okay. Any step that was strange? Okay. Let's move on to 2. Good. still proof stuff. Sine of x plus 2 pi is equal to sine. Obviously, you want to start on the left because you have something to do. So right away, you should see, oh, that's a sum difference formula. Once you apply it, things should cancel, leaving you with a sign. This is my alpha and beta. So this will become sine alpha, which is x, times cosine beta plus cosine alpha sine beta. Write that a little bigger. Okay, so right away you should see that this is going to be 1. Cosine of 2 pi or 360 is a 1 in a unit circle. Sine of 2 pi is 0. So this is 1 and 0. So this becomes sine x times 1 plus cosine x times 0, leaving you with just a sign. So using the formula should get you there pretty quick. Any questions on number 2? No, I think that was one of the easier ones. Okay, so it's okay. All right, number 3. I'm thinking of starting on the right just because I could do a double angle. Over here, I'm not sure what I would do with this. Maybe they're the same, maybe not. I haven't done these before, so let's just do them, see what happens. Starting here. So we should know cosine has three forms, right? Was the double angle. We need to pick one. Let me look them up. Double angle. I'm gonna choose the one that has sine in it, because maybe it'll cancel one this sign. That's my logic. Okay. So I'm thinking let cosine 2x equal this version of the identity. That makes sense. So I chose that for a reason, because that'll get me there the quickest. Okay. This is double angle identity. So cosine 2x equals 1 minus 2 sine squared x. And I gave you 3 different ones, but I chose this because it's going to cancel this sine squared. So at this point, just separate the fractions. Get 1 over sine minus that other thing. Once you separate, you see what's going to happen, right? Is it clear? These will be gone. This is the only time you can cancel. You can't cancel here. You only cancel when it's a product or if it's isolated. Remember, we talked about that. So this guy right here, 1 over sine. Well, let's do the algebra first. Show more steps. This becomes minus 2. Just basic algebra, right? Nothing fancy. Then right after, 1 over sine is cosecant squared x minus 2. That is the reciprocal. Yep. Sorry. First day back, I'm really tired too, so forgive me. I'm staring at my phone all morning. Like, should I just not go? Stay home. A lot of willpower. I'm sure you all feel the same. But we'll just do this review and call it a day. Okay. Any questions on 3? Is it okay? No, I'm hoping to have those graded by this week. I did not do any work on the break. And I hope you guys had some time to relax too. All right. Let's move. I'm going to turn the page in just a moment. After this is just solving things. No more proofs. Also, I only put 9 questions, so I'm just gonna let's pretend there's 10 and give you free 10 points. Okay. Let's all assume you got the 10th one correct. Sound fair? All right. 4. So given the following. Given that cosine x is equal to negative 3/5 and x is between pi x and 3 pi over 2. All right, there's number 4. Find sine 2x and cosine 2x. All right. I'll go ahead and write 5 here because I'm gonna do them kind of together. Sine of x over 2 and cosine x over 2. So we need to find sine, right? We also need to determine what quadrant this is. What quadrant are we in here? Yeah, it's going to be 3. So that's something you have to figure out on your own. So it's quadrant 3. Okay. So build your triangle. Sine and cosine are both negative here. Okay. So negative 3 and 5 is your hypotenuse. Hypotenuse is never negative. Just always leave it positive. The y will be negative, and this is a 3, 4, 5 triangle. If you try to solve it, you're going to get a 4, but you're going to choose negative because we got to do plus or minus. Okay, so when you do Pythagorean, you square root both sides. So you would choose negative 4. All right, so that means that sine is negative 4 over 5, and cosine was given to us as negative 3 over 5. Okay. Now we can answer number 4 and 5. 4 sine 2x is equal to 2 sine x cosine x, which is 2 times sine, which is right there. So that'll be 2 times 12. That'll be 24, 20, oops, sorry, 24 25ths. $24 25ths. You agree with that? Okay. Cosine 2x is equal to, now there's a few of them. I'll choose this one. For no reason. You can choose any of the three, doesn't matter. So plug in your cosine and square it. Plug in your sine and square it. You should get 9 25ths minus 16 25ths. What's that going to be in a
-7.
Yeah. Negative. Okay. Any questions on number 4? Or finding the information we need? Are those two parts clear? You don't have to worry about signs for these two because there's no plus or minus. Okay. The half angle you will have to worry about. So number 5. Note that x over 2 this would imply that x over 2 is over here. This is quadrant 2, correct? You want to double check? So in quadrant 2, it's supposed to be a double arrow. It's poorly drawn. So this implies that quadrant 2. Okay. In quadrant 2, cosine is negative. So when we do this one, I have to choose the negative version. Okay. So sine of x over 2 is equal to plus or minus the square root. Let me double check. There it is. 1 minus cosine over 2. And then the cosine x over 2 is equal to plus or minus 1 plus cosine over 2. So you're going to choose positive for sine because of the quadrant here. So this becomes 1 minus cosine, we said it was negative 3/5 over 2. Yeah, actually, yeah. And then this guy would be minus, so this would be negative 1 minus negative 3, I'm sorry, 1 plus negative 3/5 over 2. Technically, that is the answer, but you should do some algebra. Up to that point, does it make sense? Okay. Minus minus, so that'll be 1 plus 3/5 over 2. Add these fractions, that'll be what? 5 over 5 plus 3/5, that'll be 8/5 divided by 2. The 8/10. This guy will be 1 minus 3/5 is 2/5 over 2, which is 1/5. I'm just gonna let it go there. I mean, unless you care about the fraction step. These, you want to see more details on this? I could use it, do it on the next page. Is this okay? Do you see how we got to here? If you got to this point, I'll give you most of the points. I'm not gonna grill you too hard on the fractions. I mean, you should know it, but if you got to here, you showed me that you understand the pre-cal step. If you fell apart after, and you showed me that your algebra is weak.
Isn't it, two, if it's five, like a positive five? That's even two.
This one?
Yeah.
Yeah, this would be 2/5 over 2. So the 2/5 would become, let's double check. We have this going on, right? On the inside. There should be this. So this 2 cancels
Oh,
that
that's
one.
like how the reduced, right? Okay.
Yeah,
Okay.
yeah, I reduced down. This one I didn't reduce. This should be 4 over 5, which then square roots to 4. Is out of space. Anyway, any question on 5? You can rationalize this and simplify a little further if you like. I'll do it. You can do it on the next page, I guess. Oh yeah. All right, so 6, 7, 8, 9 are. If you can do 2 of them, you should be able to do the other 2. I'm hoping y'all did well on that part. Number 6 said 4 cosine squared x equals to 2. So isolate the trig function. Divide by 4 on both sides, you'll get to here. Which then gets you to here. Square root both sides, and that gives you your plus or minus. which then gets you, once you rationalize, you get to here. Well, let me show this. Well, you should know, you should remember that this has 4 locations, right? It's gonna be x equal to, let me pull up the unit circle. So this happens at pi over 4, first one. 3 pi over 4, 5 pi over 4, 7 pi over 4. Just looking at the circle. Is it clear how we found these?
For the bottom part, like, it says, those are like this one year, so you need to, like, oh, this is, did you multiply? Like to get this.
Oh yeah, so to get there, you would do this. Okay, so that's all solutions on 0 to 2 pi. Number 7. Any questions on 6? Okay. Number 7 was a quadratic type. So you can do the substitution if you want, or just straight up factor it. So that will give us w squared plus w minus 2. So this factors into w plus 2 times w minus 1. Right? So solve this for w, and we get to here. Change back to cosine. Because w was made up. Then you should see right away that this has no solution, right? Cosine is never below or above 1, then -1. This has no solution. If you try to solve for it with a calculator, you will see that. Cosine equal to 1 on your unit circle. X would be equal to 0. That's it. And we only have one solution for number 7. Any questions on 7? Okay. So 8 and 9, you just tack on the infinite part to these answers and you're done. So if you got these done, 8 and 9 are pretty much automatic. Well, actually, 8 isn't, but 9 is. Sorry, just noticed it changed it. So now you would only have this part. All right, so solve for isolate the sign and then square root. You'll get to here. Very similar to the last, or number 6. Square root both sides. You get plus or minus 1/2, which becomes plus or minus 1 over square root 2, which will be this guy. It's going to be the same as the other question because it's the same location. So x1 is equal to pi over 4 plus 2 pi k. X2 is equal to, what was the other one? 3 pi. X4 will be this. So the 4 locations we had earlier, just add 2 pi k from number 6. You could condense that into one solution because they all differ by what? 90 degrees, right? So you could say, you know what? One big solution. So all this is the same as x equal to pi over 4 plus pi over 2k, right? That would hit all of them forever. So I'll accept either one, doesn't matter. But you can see how you can condense it, right? Is that obvious? Or think about it. Show you the circle really quick. If you look at your circle, from here to here is 90. So let's do this at 90, and then another 90, another 90, another 90. It'll just be 90k. Pi over 4 plus 90k. In other words, pi over 4 plus pi over 2k. Same thing. Okay, number 9 will be what we had earlier. We found x to be 0, so just add your 2 pi k. So you don't really need the 0. Okay, well, actually, hold on. Yeah, make it. Any questions on 8, 9, or 8 and 9? Yeah, let me know. Let's go and take roll. Sadie,
Here.
Jadlyn, sorry, Ava, Andre, Zoe, Aaron, Michael. Michael, right? Okay. Making sure. Alexandra? No. Juan? Juliana? Not here. Epifania? Andrea? Kimberly? Diego? Teresa? Hunter? Angelica? Connor? Okay. All right, guys, we'll call it here, have a chill day back. Wednesday, Friday, we're gonna get back into the new chapter, okay? So test 3 material begins Wednesday.